Welcome to Bibliophile. Bibliophile is a non-commercial personalized movie and books recommendation engine. Recommendation systems have become extremely common in recent years and are applied in a variety of applications. The most popular ones are probably movies, music, news, books, research articles, search queries, social tags, and products in general. Now imagine that you own an online movie and books business and you want to suggest your client books recommendations based on movies they watched or searched for. Our goal is to calculate how similar these books and movies are so that we can recommend something which they would really like. But the problem arises when the user signs up on the website for the first time and we don't know about his likings or dislikings. So to overcome this cold freeze problem, we came up with a survey form in order to get all the details about the user. Our form basically consists of two sections. In section 1, we are asking users about the likings on the basis of genres, and in section 2, we get to know about the era in which the user is interested. After entering into the dashboard, user finds out the top rated books and movies sorted according to their liked genres like comedy, romance, adventure, fantasy, horrors, etc. etc. Moreover, users also get to know about the top picks worldwide, and users also sees the recommended movies and books according to the genres which he liked. Now switching over to the backend to see how all this actually works upon. There are basically two files in the movies dataset, namely movies and ratings. The former one consists of the list of the movies, their titles and their genres, while the latter one consists of ratings of the users given to the different movies and the respective timestamp. For the pre-processing part, we have created a one hot encoded matrix with the genres as a column values for different movie IDs. This would further be used in gathering information about the closeness of the users. There are three types of recommendation techniques, namely content-based, collaborative filtering, and hybrid filtering. The collaborative filtering is further divided into two techniques, model-based and memory-based. Model-based comprises of different predefined models like clustering and association techniques, while the memory-based filtering technique is further classified into user-based and item-based. In our project, we are using user-based technique. For the top picks column of the website, we are using content-based filtering, where we calculated the mean rating of every movie in the dataset and later printed the highest rated movies. Now, for recommending movies according to the user's preference that are already stored in the dataset, we have used collaborative filtering using k-nearest neighbor techniques, which calculates the closeness of the test user to all the trained users and then selects the top closest users among them. This closeness score is basically the Euclidean distance between the ratings given by the different users for the same movie. Say for user 161, the following 7 users have the least Euclidean score. We then create a full list of all the movies rated by the 7 users and extract a common list of movies which have already been watched by the test users and recommend the highest rated of the remaining movies to him. The common movies for the different test users are shown as follows, and the new movies recommended to the users are as follows. Another way for calculating the closeness is based on genres. Here firstly we group the data by user ID so that we have the results as follows. Here as we can see that the user 1 has watched 18 movies related to the mystery, 9 to the war, and so on. The distance or score between the user 1 and user 2 is calculated as the square root of sum of squares of differences of the individual genres. We then validate our results by using standard KNN from the sklearn library and observe that the root mean square error of our model was 0.115, which is the acceptable range. Again, we calculated the full list, the common list, and the recommendations by taking genre as a factor in Euclidean score, and the results are as follows. Now we compare both the techniques. The techniques with the higher number of common movies gives us the better result because it shows that the trained users are better correlated with the test users. The graph is the proof that the model with the rating as a closeness factor gives us the better recommendations as their common movies are higher in number than the other one. The x-axis of the graph is the test user IDs and the y-axis shows the number of common movies recommended to them. In the phase 2 of this project, we recommend books. For that, we firstly read the books dataset which has the following attributes: wiki ID, title, author, publication date, and genre. We calculate the total number of unique genres in the book dataset, which comes out to be 227, and the unique genres in the movie dataset were only 19. So we calculate the relationship between the books and the movie genres using NLP. Using this library, we calculate the synonyms of each genre in the movie set and its similarity score with the each genre in the book set. The genre with the highest score is returned as its relation. Now say for user 161, following movies were recommended. And these are the tags related to those movies. We then evaluate from our relation metrics which books tags are related to these movies tags. We filter out the final recommendations by using these book genres. The top 5 books related to the max number of these genres are then finally recommended.